Look around, and the universe appears overwhelmingly complex. Planets hurtle through space, weather systems spiral, and crackling arcs of lightning jump across the sky. There is a massive amount of physical information happening all at once. Underneath that complexity is a highly structured mathematical foundation. Physics does not rely on an infinite, arbitrary list of measurements. Every physical event you can observe is a combination of exactly 7 fundamental base quantities. For centuries, humanity anchored its measurements to physical objects. A standard kilogram was an actual cylinder of metal sealed under glass. But physical objects are subject to environmental degradation, and relying on localized artifacts makes the data fragile. Modern physics uses a more rigorous language, dimensional analysis. Instead of dealing with messy unit conversions like pounds to kilograms, we express physical quantities strictly as powers of base dimensions, enclosed in bracketed matrices. By moving away from raw, memorized units into this bracketed syntax, we gain a system to verify the dimensional consistency of any physical model. The starting nodes of this dimensional system rely on 3 foundational blocks: mass, represented by a bracketed m, length, with an L, and time, with a T. Derived physical quantities are base nodes multiplied or divided. Divide length by time, and you get velocity, written as L t to the negative 1. Divide by time again, and you get acceleration, L t to the negative 2. Any mechanical movement in the cosmos, from a falling apple to an orbiting moon, can be structurally defined by combining just these 3 letters. As equations get more complex, building every dimension from the 3 base nodes becomes inefficient. To manage this, we use keystones, consolidated dimensional matrices that represent the most common physical relationships. Our first keystone is force. We start with Newton's second law. Force equals mass times acceleration. We swap the mass variable for our m block and acceleration for our L(t-2) block. Multiply them together, and you get mLt-2. This is the force keystone. The second keystone is energy, or work. In classical physics, work is force applied over a distance. So we take our force keystone and multiply it by 1 more length block. That gives us mL²t-2. By internalizing the dimensions for just these 2 keystones, force and energy, you can derive the dimensions for almost any other mechanical quantity in physics. We can apply these keystones to the macro universe, starting with Newton's law of universal gravitation. The gravitational force equals the constant g times the 2 masses, divided by the distance squared. To find the dimensions of the gravitational constant g, we first isolate it algebraically. Now substitute the dimensions. We drop our force block in for F, multiply by length squared, and divide by mass squared. Simplify the matrix, and we get m-1 L³t-2. The same logic applies when we transition from the orbit of planets down to the microscale of quantum mechanics. Max Planck defined the energy of a photon as E equals h nu, where h is Planck's constant and nu is the frequency. To derive the dimension of Planck's constant, isolate h by dividing energy by frequency. Using our energy keystone, mL²t-2, and dividing by the dimension for frequency, t-1, we arrive at mL²t-1. Gravity and quantum mechanics describe physical phenomena at vastly different scales. Yet the constants that govern them are both built from the same limited set of primary dimensional elements. This system extends beyond mechanics. To map electromagnetism, we simply introduce a 4th foundational node, electric current, represented by A for ampere. Electric charge is the product of current and time. Its dimensional bracket is A times T. Now we use our force keystone on Coulomb's law. By isolating the electrostatic constant, K, and plugging in our force and charge matrices, the relationship becomes clear. The math resolves to mL³t-4A-2. Because the permittivity of free space, epsilon naught, is the inverse of K, we simply flip the exponents to find its dimension. Even the magnetic field, B, is tethered to this system. By using the magnetic force equation, force equals B times current times length, we can isolate B and resolve its dimensions using our force keystone. Electricity and magnetism are new combinations of these foundational keystones, expressed in the same dimensional language as mechanics. All of this structural mapping is governed by the principle of homogeneity. This is the syntax of physics, dictating whether a physical equation is actually possible. Different dimensions can be multiplied or divided to produce entirely new physical quantities. Distance divided by time creates velocity. Mass times velocity creates momentum. However, you can only add or subtract terms that possess the exact same dimensional matrix. If you try to add a length directly to a time, the equation fails. There are specific exceptions. Ratios, like mechanical strain or refractive index, are calculated by dividing a unit by itself. The dimensions cancel out, leaving a dimensionless quantity, m0, l0, t0. This leads to the angle paradox. An angle is the ratio of arc length to radius, length over length. Dimensionally, it is zeroed out, yet it possesses a practical measurement unit, the radian. The principle of homogeneity acts as an analytical filter. It allows a scientist to evaluate a theoretical formula and disprove it on paper without conducting a physical experiment. This diagnostic rigor also applies to mathematical operators. Sine, cosine, logarithms, and exponents act as dimensional boundaries. You cannot take the sine of a kilogram or put a meter in an exponent. These operators can only ever process purely dimensionless quantities. This theoretical clarity dictates the physical world. The dimensional blueprints we have mapped are the requirements for the precision-engineered physical standards used in modern metrology. The rule is absolute. If the dimensions of an equation fail to balance across the equal sign, the underlying physics model is objectively false. Physics is often taught as an exercise in rote memorizing massive tables of formulas. However, the dimensional method offers a more analytical approach. The relationships cascade from 4 basic root nodes, through the keystones of force and energy, and out into the constants of gravity, quantum mechanics, and electromagnetism. Internalizing this methodology changes how you view physical equations. They are no longer isolated facts, but an interconnected web of logical certainty. Mastering this syntax provides the means to verify the foundational logic of physical reality.